Hello again, class. This is Chapter 9.1b, using graphs. And first of all, I just want to tell you that your graphs in your notes are going to look a bit different than the one here on Smartboard because I needed to recreate the graphs on Smartboard. I used to teach this lesson using a transparency on an overhead, and the graph would have looked exactly like yours. So you might have to just watch a little more closely. Graphs can be used to give us information. Sometimes we can use that graph to estimate, and that's the concept that we're working with here in part 1. I give you a graph that shows the cost of different cell phone calls. Points are connected because the phone company charges for the exact amount of time a call takes. You will note that along the horizontal axis, we have the number of minutes, and along the vertical axis we have the cost in dollars. You will also note that there is a title to the graph, cell phone cost. Every dot represented on the graph is for 1 minute, 2 minute, 3 minute, 4 minute, 5 minute, 6 minute. But the question is, how much would it cost for a call of 3.5 minutes? Step 1 says to draw lines to locate the value on the vertical axis that will correspond to 3.5 minutes on the horizontal axis, and then step 2 says we can estimate. One of the easiest ways to do this, for me anyway, is since my call is 3.5 minutes, I'm going to start over here is actually 0. That's why there's no charge, because obviously they can't charge you for talking when you're not spending any minutes. I'm going to move over to 3.5, which should be approximately right here. Now, a ruler can help you do this, so you might want to consider using a ruler. And I don't have a ruler, so I'm going to make a dash line up to the graph that we are given. Now, I want to read the cost off on the vertical scale, so I'm going to make some dash lines over to the vertical scale. Now here's where you have to consider, what does each line or interval mean? I have a 1 marked up here, so that would mean that down here is actually 50 cents. Between the 1 and the 2 is going to be $1.50. Now my line is a little above the $1.50. It's hard to see that. So the estimation would be about $1.60. And on your graph, it's probably more clear that we are indeed a bit over that $1.50. Now the next time, they want us to look for a cost of a 4.5 minute call. We would do pretty much the same thing. We would, on our horizontal axis, we would go over to 4.5. We would make our dash line up to where we want to be, and then over to where we want to be vertically. Now it's probably a little easier to see on your graph, if you draw your lines, that you're just a nudge over the $2. So the book says a good estimate would be $2.05. Although I probably wouldn't have a problem if you had said $2.10. Probably not even had a big problem if you said $2. Try not to be like 10 cents off or something is the main thing. Now that is estimating from a graph. The second thing is that sometimes the graph doesn't give me the complete information, and I'm going to use that graph to make a prediction. And I'm going to do that by extending the graph and then finding the corresponding value on the appropriate axis. To extend a graph, this is again where a ruler comes in handy. I would match up my ruler with the line with the information I'm given on the graph. And then notice that they put it on as a dashed line up here on the right side. So for temperature scales, they're going to be comparing degrees Fahrenheit to degrees Celsius. Their dot ends at the fact that 60 degrees Celsius is approximately going to be 140 degrees on Fahrenheit. Again, if I look at my intervals, they give me from 0 to 40, so the line in between is 20, 60, the line in between has to be 100, and this has to be 140. So you have to kind of sometimes read in between those lines. For 160 degrees Fahrenheit, the Celsius temperature is going to be slightly more than 70. Now this time, they want me to go to from 160 degrees Fahrenheit. That means I have to start on my vertical axis or my vertical scale and take this over to the line that I have extended. And then, again, using a ruler helps to bring it down here. Now, if I look at my horizontal axis or horizontal scale, this would be 10, this would be 30, 40, 50, 60, 70. And you'll notice that it's a little bit more than 70. So I'm going to estimate. Well, it certainly isn't 75, so I'm going to call it 72 degrees Celsius. Would I be okay at saying 71? Maybe. Would I be okay at 73? Yes. Would I be okay at 75? No, because it clearly is not halfway from 70 to 80. Now notice what they did in the last problem. In the last problem, they said, what we want you to do is start out at 80 degrees Celsius and figure out the Fahrenheit. The Celsius scale is horizontal. 80 is over here, way on the right, so I'm going to have to make a dash line all the way up to where I extended, and then, again, here's where a ruler comes in a whole lot handier than what I'm doing. Moving over to my left. Now, 160, I know that goes 120, 100, 160. This would be 180 up here. So I'm at probably around 170 something, because I'm midway between 160 and 180. And I could be 172 to maybe 175. So I'm going to estimate as close as I can, and I'm going to say 175 degrees Fahrenheit. Am I sure that that's a precise answer? Not unless I actually put it through a formula, which they do have, but it's a good estimate. Am I going to say 162? No. Am I going to say 187? No. Am I going to say 179? No. I'm probably going to be closer to around 170 to 175. And that concludes Lesson 9.1b on using graphs. Catch you next time.